Greetings folks. In this video I'm going to try and show you how to set up a simplified implementation of INAV just using the basic modes that we actually need to fly. We can add all the extra fancy stuff later on, but the aim of this is just to get you up and flying with a minimum of fuss and to have an INAV setup that just works well. This video isn't aimed at beginner flyers. You'll need to know how to fly a plane already and how to set it up properly. How to solder up your flight control board and connect it to your computer, and you will have to have INAV configurator all working and all that sort of stuff. First thing we're going to do is set up your plane so that it will fly using 100% weights and 30% expo and no trims. That's kind of the default setup of INAV. You're going to make your life a lot easier if you have a plane that's easy to fly and has really good access into the internal so that you can get access to the flight control board. And this is the Finwing X-Bird, modded with wider wingspan to make it nice and smooth flying. This is one of my favourite INAV models now, and it is very efficient and easy to fly and easy to work on too. First step, before we even think about the flight control board, is to get the throws correct. The aileron throws and the elevator throw. We haven't got a rudder on this one, so we don't need to worry about that. What we need to do is grab a servo tester or connect up a normal receiver and radio using 100% weight on the sticks or 100% twiddle of the servo tester knob and determine which holes you need to connect the push rods to give you reasonable throws at 100% weight. So I'm just testing the elevator throws now with the push rod connected to the outer holes, and that is way too big. I know that because I've flown this plane before, and that was just way too twitchy with that much throw, so I'm going to move the push rod down a couple of holes to the middle hole. Now that's effectively divided the throws in half, so that is much more reasonable. Plenty of throws for this plane, so I'll leave it at that. And I'd take the plane for a fly with those throws and work out if I need any trims. If I do need to trim the elevator, then I would do it mechanically like that. So I'd adjust the length of the push rod going to the push rod connector there to get it flying nice and level. Don't touch the radio trims. INAV ignores radio trims in all modes except for manual, so if you're using your radio trims to trim out the plane properly, it might work for manual, but it won't work for any of the other modes. So forget about the trims. The trims can't be used in INAV. And also, while you're flying, work out the correct centre of gravity point too. So your plane is flying nice and level, in control, 100% weight and 30% expo. Once you've sorted out the throws and the trims mechanically, you'll be well advanced along your trip to Simplified INAV. You won't need the auto trim and auto tune and all of that sort of stuff. You can forget about that for the moment, and it'll be much quicker and easier. If your model is a flying wing, of course you'll be using an elevon mix on your control surfaces, so that's 50% elevator, 50% aileron. So just keep that in mind when you're working out the amount of throws you need. If you're using a servo checker, just keep in mind that only half of the throw will be elevator and the other half will be aileron. You can do a test flight with a normal elevon mix in your radio before you implement INAV, but when you do implement INAV, you will have to remove that elevon mix. You can have no mixing at all with an INAV model. Now this is how we set up the standard INAV model in your radio, and this works for normal planes, flying wings, quads, absolutely everything. This is the way you must do it. So start a new fresh model slot. EdgeTX will already set it up with inputs. I would get rid of all those inputs. They're just going to confuse things. We don't need inputs. Start with a fresh mixer page, and channel 1 will be ailerons. 100% ailerons, no expo. Channel 2, 100% elevator, no expo, no nothing. Channel 3, 100% throttle. And channel 4, 100% rudder. Whether you've got a flying wing, a quad, a plane, whatever. This is how you must set up the first 4 channels. This is what INAV is expecting, and if you use anything else, you're going to have problems. And now we need to set up some of the modes. So arming on channel 5, I always have arming on channel 5. That is sort of best practice, especially for Express LRS. And I'm going to use this switch down the back here, 2-position switch, SE. Now some modes on channel 6, and I'm going to use a 3-position switch here, SC. So that will be acro, angle and manual modes. And on channel 7, I'm going to have a return to home, which will be on the 2-position switch at the back there, SF, on this radio. So we have arming on SE, modes on SC, and return to home on SF. We can, of course, add more modes later on, but that's all we need for the basic setup. Okay, it's time to look at the flight control board now. This is what I'm using. It's a Maytech F405 Wing V2. Really nice little board. FPV camera is a Runcam Link DJI compatible HD FPV. Receiver is an Express LRS receiver, UART connection, and I have a GPS as well. That's just some random GPS that works. So we will open INAV Configurator and connect the flight control board. And you can pick up your board and move the animation around. That's always a lot of fun. I like doing that. Okay, so let's go through the setup. Calibration, you do your calibration, just follow the prompts there. Once you've done your calibration, you'll get all the blue ticks there. So we move on to mixer. Now we can choose the plane type here. This is why we don't do any mixing in the radio at all. This is where the mixing is done. We've got an airplane here. So you've got a V-tail, flying wing, all those different choices there. If you were doing a flying wing, you would choose that. We have an airplane, so let's look at what they've offered us. And here's the standard mix for an aeroplane with a single motor. Stabilised pitch or elevator on servo 1, ailerons on 2 and 3, and rudder on servo 4. We don't have a rudder, so we can ignore this really. We can actually delete it if we want to, but for simplicity, let's just leave it there. And you can see these colour coding here. It shows you on the little diagram where you actually plug things into. S3 from the board is the elevator. S4 and S5 are the ailerons. If we had a rudder, that would be plugged into S6 on the board. Let's see what a flying wing would give us. We'll change the mix. Load mixer. And you can see we have the single motor and just 2 servos now. And that gives us the mix 50-50 roll and pitch, or elevator and aileron on servo 1, and -50 and 50 on servo 2. Now later on we may need to come back to this screen and reverse the weights on some of these if the control surface is working in the wrong direction by wiggling the sticks. Then you would come back into here and reverse the weights. But we'll come back to that later. We're dealing with a plane anyway, so we'll go back to aeroplane. Okay, moving on to outputs. We do need to enable motor and servo output. We don't need to play with any of these other things. If you have a BL Heli ESC, you can choose the correct protocol here, but everything will still work on standard. If you have fast digital servos, you can increase the refresh rate here, but everything will still work on 50. So we'll just leave it as that. Now moving on to ports. This is where we tell the flight control board which peripherals are plugged into which UART. Serial receiver is already checked for UART 2, so we'll leave that as it is. I'm going to plug my GPS into UART 4, so I will select GPS there. And I'm going to plug my HD FPV gear into UART 3. So for my particular gear, I need to choose MSP display port. If you just have analog FPV, you don't need to make a selection there at all. Configuration. Nothing we need to do in this section here. It has already detected the correct accelerometer and barometer that are on my board. A little quirk with the version 2 of the F405 wing board is that it uses 150 as the current meter scale instead of 317. So I have to manually change that there because it doesn't automatically pick it up. But if you're using a different board, you shouldn't have to do anything there. If you're mounting your board with the arrow facing the nose, there's nothing more to do here. I'm actually mounting mine with the arrow facing backwards. I need to tell INAV that the board is 180 degrees rotated in yaw. We are using a GPS for navigation and telemetry, so we'll have to click that button. Now, remember I said that you can't use the radio trims in INAV. Well, this is where INAV does it for you. It will continuously trim the servos when you're flying in any mode other than manual. It will sort of detect what servo trim is required for level flight and then save that so that when you flick to manual mode, the mid servo trim will be saved and will be correct. Failsafe. Now this is important. What do you want it to do on a failsafe situation? Well, we want it to return to home, save and reboot. PID tuning. So these are the stabilisation parameters for roll, pitch and yaw. And these days they are pretty good out of the blocks. The only parameter I might play with is the pitch feed forward. When I have everything connected up, I'll have a look at the amount of throw we have in acro mode or in angle mode compared to manual mode, and I will play with this pitch feed forward value until the throw in angle or acro mode is about 80% of the throw in manual mode. And that's a great starting setup. You know you're going to have enough elevator throw for your first launch. Rates and Expo. This is where you tell INAV the maximum roll rate, the maximum pitch rate that your plane is capable of. And so when you bang the sticks over at full extent, this is the roll rate that INAV is going to try and match. These numbers are pretty good for a mild performance plane, so I'm going to leave that as it is at the moment. If you're using auto tune, it will adjust these values for you, but I would suggest just leaving them as they are to start off with. Remember, we set the plane up to operate at 100% rates and 30% expo. Well, here's where we can change those values if we need to. If we need to reduce the rates and we can't do it by moving the push rod to a different hole, this is where we can reduce the rates. Same as you would reduce the rates in the radio with a normal model. And here are your expo values as well. You can change them later on if you need to, but I would suggest leaving them as they are to start off with. And in mechanics, we'll scroll down to fixed wing level trim. Most planes need a few degrees of nose up attitude in pitch to fly level, and this is where we tell the board what that angle of attack should be. Usually I start with 4 degrees, positive 4 degrees, and when I fly the plane in angle mode, I'll see whether it's gaining altitude or losing altitude, and I'll make adjustments if I need to here, but 4 is usually right for my planes. Advanced tuning. At this stage we're not using auto launch, so we can ignore all of this stuff. We can come back to it later on and play with it if we want to. Return to home settings. The only thing you really need to worry about is what altitude you want it to return to home at, and this is set at 50 meters, which is fine for me. If you have really tall buildings or trees around you, you may want to increase that to 70 or 100 or whatever suits your situation. Fixed wing navigation settings, you don't have to touch anything here, and that's all we need to worry about on that page. Nothing to do in programming. Now we'll go to the receiver page. First thing we have to do is select the serial receiver provider. I'm using Express LRS, so I need to choose Crossfire. If you're using S-Bus, you would leave it as S-Bus. If you're using FlySky, you might choose iBus or whatever is appropriate to your receiver, but Crossfire for me. Save and reboot. Okay, moving on to modes. So we'll set up an arming switch. Remember we had a 2-position switch on channel 5, so that is going to be this one. It's going to be armed in one position and disarmed in the other position. Then our modes we had on channel 6, 3-position switch, so I'm going to leave angle in the middle and manual down the other end, so also on channel 6. So that will give us acro when the switch is in that position, angle when that switch is in that range, and manual when the switch is in that range. And now we'll set up the return to home switch. That's this one here. That was on channel 7. 2-position switch. So back position is going to be acro, forward position is going to be return to home. Remember to save. Now the GPS. Make sure the GPS for navigation is selected. Look at your GPS specs and see if it supports uBlock 7, which is just a slightly faster protocol, or leave it on uBlocks if you don't know what you're doing. Ground assistance type, you can leave that disabled or auto detect or whatever you feel like doing. If you're in a region that can see Galileo satellites, then you can select that one to get a few more satellites picked up. And that's about it for setting up the GPS. Later on, when we actually connect it up, we'll have a look at this total messages. And if that is actually changing, that shows that we have connected it correctly. If it's sitting at 0 like that, it means you may have to switch the RX and TX pins, but we'll come back to that later on. And OSD. Now, depending on which style of FPV gear you have, you will need to make a selection here. If you have analog, you'll select PAL or NTSC, I guess. I have DJI WTF, so that's what I'm going to choose there. Because I'm using Express LRS, I like to see the link quality and the transmitter power shown there. They're useful parameters, better than RSSI for Express LRS. But you just need to go through all the options here and position things on the screen as you would want them. And then finally go to the CLI, type diff, DIFF, hit return, and this will show you all the changes that you've made, and you can save them to a file over here, save them somewhere that you can find later on. That gives you a text file with all your choices, which you can copy and paste back into the CLI command if you need to later on to redo anything that you've done. Now I'm going to connect the receiver, and I have plugged in the USB cable there because that provides power to these three UARTs here. So you can see they have 4.5 on the voltage pins. That is very useful for setting up because you can power up your receiver and your GPS without having to connect your flight battery. That's sort of a good feature of this board. Not all boards are like that. I have my receiver and I have my radio turned on. It is definitely bound to the radio. So I have grounded voltage and RX and TX, making sure I get the polarity the correct way around. There we go, that's receiver powered up. And yep, we've got a solid light, we've got signal on the radio, and that is definitely bound. So now I connect the RX and TX. I don't actually remember which way the RX and TX are there, so I'm just going to have to plug it in and see what we see. And I am connected. You can see I'm getting a response on the screen there. If you're not getting a response when you wiggle your sticks, you're either not bound or you've got the wrong choice in the receiver protocol, or you haven't connected it correctly. And now we need to check that these graph lines move to the right when we move the sticks up and to the right. So they're all correct. They're all going in the correct direction. If you found one of these graphs was going in the wrong direction, then you need to reverse the channel in the model in the radio. This is the only time you would change anything in the radio once you've set up your basic model. If you move the sticks up and to the right, all the graphs move to the right. Okay, now let's check the modes. With all the switches in the back position, we're in acro mode. You can see acro is lit up blue there. That is the default mode. We will arm it, so that arming is working correctly, and we will switch to angle mode. Very good. Manual mode, very good. And return to home as well. So all the modes are working. Now it's time to connect the GPS, and we set up GPS on UART 4, which is also powered by the USB cable there. So we'll plug that in, and we have power on the GPS, so that's good. RX and TX, again, I don't know which way they're meant to go, so we'll just plug them into UART 4 anyway. So now looking at the GPS screen on INAV Configurator, and we can see total messages isn't changing. So we've got the RX and TX around the wrong way, so I'll just switch them now. There we go, you can see that change. The total messages are counting up, and our GPS icon has turned blue, so that is all good now. GPS is connected correctly. Now I'm going to connect up the FPV gear, and this system needs 9 volts for power, so we get 9 volts on the VTX pins over here, so I'll power it from the voltage and negative there. Now the voltage on these pins comes from the flight battery, so that's not going to power up the camera just at this stage. And the UART we chose was UART 3. So we'll plug into the RX and TX. Not absolutely sure which is RX and which is TX, but we'll see. If we don't get OSD items in the goggles, then we know we need to switch these around the other way. But we'll need to plug in a battery to check that out. Now I hope you can see this in the goggles, but I am getting the OSD in the DJI goggles, so that shows that video transmitter is connected correctly to the UART. Alright, I've mounted the flight control board in the plane, connected up flight battery, got my transmitter there, just checking the direction of throws, and that shows my ailerons are reversed. Elevator's good, so I need to reconnect to the configurator and reverse the weights on the ailerons. I also increased the feed forward up to 110 to give reasonable throws in the stabilised modes, just to make sure I have enough throw for the first launch. Now checking again, and ailerons are working in the correct direction. That's the manual throws, that's the stabilised throws. So plenty of throws for our first launch. And now just do a final check to make sure the stabilisation direction is working. So if we lift the wing up in angle mode, aileron comes up to counteract that. If we lift the tail up, elevator comes up to counteract that. And right wing up, right aileron comes up. So that's all working correctly. And the stabilisation will always work correctly if you follow those steps. Push the sticks up to the right and the graphs on the screen travel to the right. So now we'll take it out for a fly and check that everything's working.